Okay, here's a review for the next part of the unit, Chapter 2. Some of the questions, okay, who discovered the electron? Because remember, this chapter is about atoms and molecules, and it took a lot of people to figure these out. So who discovered the electron? It would be J.J. Thomson. He's the one that did the cathode ray tube thing and realized that they had a charge. Who proved the nucleus was a small, positively charged area located in the middle of the atom? This was the gold foil experiment. Good old Ernest, and I guess I've always heard it as Ernst Rutherford. He's the one that figured out that that there's a dense middle, and he called it the nucleus. Okay, who determined the charge of the electron was negative? See, now Thomson said there was charged particles, but Millikan, he's the one that proved that it was electric. I mean, that it was an electron and that it was negative. Okay, so then remember, John Dalton was the chemistry guy that put all the ideas together. He didn't discover anything, but he wrote the atomic theory. Okay, did he say everything is made up of atoms? Yes, he did, and he was right on. A compound can have different number of atoms? No. If you have a compound like water, H2O, it's always 2 hydrogen, 1 oxygen. If you change the number of atoms, it's a different compound. Okay? Atoms cannot be created or destroyed by ordinary means, and that's very true. Okay? They've kind of had to change it a little bit because we do have extraordinary means. We do have nuclear. But at the time that Dalton wrote this, nuclear wasn't in there, and he was right if you go by just normal chemical changes, not, extraordinary like nuclear. Okay? Many parts of Dalton's theory have been disproved today. No. Besides the nuclear thing, which, like I said, is extraordinary, everything he said was true today, which is pretty cool because he wrote this right around like 1890, somewhere around in there. So you think about it, that was a lot of years ago, and he didn't have a lot of fancy equipment, but he was a pretty smart dude. But, he's a chemistry teacher, so that makes sense. Okay, so now when you're trying to find, remember, we have the elements that are on the periodic table, and they have the mass that's listed on the table is the protons and the neutrons added together. Well, elements have the same number of protons and electrons, but their neutrons can change. So the mass that's listed on the table is actually the average of the isotopes, and not just taking the three and averaging them together, but you also have to take in their percent. Okay, so here we have an example. We have magnesium 24, that's its mass, and magnesium 25 and magnesium 26. So this is the three isotopes for magnesium. Most of it is 78.7% is magnesium 24, but we also have magnesium 25 and magnesium 26. So what you do to find their mass is you take the mass that they have times their percent. Now remember, percent, we have to change this back to a decimal, so we have to move it over 2. So we would take 24 times 0.787. We take 25 times 0.1013, and we take 26 times 0.1117, like I did here. And again, the trickiest part of these is to make sure you move that decimal over. And then you add them together, and if you look on the periodic table, you'll see the mass of magnesium is 24.3. So, this is a way you can check to make sure you're doing it right. So you take their mass times their percentage, and again, make sure you turn it back to a decimal, and then add them together. That's how you find the mass of isotopes. Okay, here's another one. Calculate the mass of an element. If 60.4% of the atoms have a mass of 69 and the rest are 71, so I would take 100 minus 60.4, which would be what, 39.6. So I'd take, instead of 60.4, 0.604 times 69, and I'd get 41.68. And then, like I said, I took 100 minus 60.4 and got 39.6. And I multiplied that. So when I add these together, I get 69.8. Well, now all I have to do is look on the periodic table and find an element that has a mass of 69.8, excuse me, and you'll find out it's gallium. Okay? So you can use it when you have an unknown to find what it is too. But again, when you're finding the mass, it's taking the mass they give you times its percentage. But again, make sure you change that percentage to a decimal. Move it over too. Okay? All right, the other thing to remember is that the amount that you start with and the amount you end with are the same. That's the conservation of mass. They change forms, but the amount never changes. So if I have 11.24 grams of cadmium and I convert it into cadmium oxide, so CD, and then I change it into CdO, I need to figure it out. Well, all I'd have to do, really, this is the total mass. This is the mass of the cadmium. So the difference between these two must be the mass of the oxygen. Okay, that's all you'd have to do there. The thing to remember is what you start with and you end with. Amounts are the same. They change forms and all kinds of stuff like that, but the amounts are the same. That you can watch on your own. That talks about periods and then groups and all that. You can watch that. You don't need me to watch it with you. So that's on your own. Okay. Okay, so we're going to find the number of protons, electrons, and neutrons in each of these isotopes. Okay, so when I write it like this is carbon, and then the 12 tells me its mass. Okay, if I look it up on the periodic table, I find out that its atomic number is 6. That's the number on top of the chart. So if it's 6, it has 6 protons. That's what atomic number is the number of protons. Well, in an atom, if you have 6 positive charges, you also have 6 negative charges. So the protons and the electrons are going to equal each other in an atom. And the reason for that is an atom doesn't have a charge. So you have to have them when you do that. And then to find the number of neutrons, you take the mass. Excuse me a second. Shut up, dogs! Oh, dogs, I'm telling you. Okay, so you take the 12, this is its mass, minus the atomic number, which was 6. So 12 minus 6 is 6. So it actually has 6 protons, 6 electrons, and 6 neutrons. That doesn't happen all the time. Okay, here's another one. Scandium, and 45, this is its mass. Okay, so if you look up scandium on your periodic table, its atomic number is 21. That means it has 21 protons. So if it has 21 protons, it also has 21 electrons. Okay, they equal each other. And then if I want to figure the number of neutrons, I take 45 minus 21. And I get 24. So scandium 45 has 21 protons, 21 electrons, and 24 neutrons. Okay, chlorine 35, and again, this dash 30 is his mass. Okay, so you don't have to look up the mass in the chart. That's the average mass anyway. Okay, so if you look up chlorine, its atomic number is 17. So it has 17 protons. It has 17 electrons. These two equal each other. And then if I want to figure the neutrons, I go 35, the mass, minus the number of protons. That gives me the number of neutrons. So chlorine would be 17, 17, and 18. Okay. Then the last part of the chapter, we talked about naming compounds. Okay. And using the stock system. So the hardest ones to probably name are where you have to put this Roman numeral. Well, what this Roman numeral is the charge. Well, how do I figure out the charge? Well, the back half I'm going to know. So if I know the back half, I can figure out the front half. Like in this one, chlorine is -1. And there's 2 of them. So there's 2 negatives. So there must be 2 positives. So copper must have a charge of +2. That's where the 2 comes from. You guys, this number never goes down here. So it's never Cu2 if it says copper 2. Copper 2 +2 is its charge. If I rewrote this and I would put Cu with its +2 and Cl with its -1, when I crisscross my charges, I'd get this formula. Okay. When I taught high school, I used to tell my kids that if you write this number as the subscript, I get to shoot you in the face. It was just with a Nerf gun, but you know, you get the idea. Okay, so how do I figure this one? It's iron oxide. That I know, but which iron is it? Well, oxygen has a -2 charge. -2 times 3 is -6. So this side has to be +6. 6 divided by 2 is 3. That's where the 3 came from. Okay, gold chloride. Okay, chlorine's -1. 3 of them, that's -3. So this side has to be +3. That's why it's gold 3 chloride. That's how you get the Roman numeral. These guys, if you look on the periodic table that I told you to run off the ion one, they have split boxes, which means they have more than one oxidation number. You have to tell me which one it is. Okay, this one, to figure it out, I know it's cobalt and it's nitrogen or nitride. But which one is it? Well, nitrogen's -3 and it has 2 of them, so that's -6. This side has to be +6. 6 divided by 3 is 2. That's where you get the number from. This is titanium, and again, fluorine's -1. There's 3 of them, so this side has to be +3. And again, I'm getting the charges from that chart that I told you to run off, that chart of ions. Okay, molecular, remember, you do not have to worry about charges. All you have to worry about is look at what you got there, and then you use the prefixes. It's mono, di, tri, you know, I would write that on the back of your periodic table if you want. But what I would do when you're doing these is you write the symbols, carbon and iodine, and then you look for prefixes. This one doesn't have one, so it's just C. Tetra, iodide, iodine is there, and tetra is 4, so it's Cl4. Again, don't worry about charges, don't worry about crisscrossing. You don't have to do these because these are molecular compounds. How do I know they're molecular? They're two nonmetals. If you put a metal and a nonmetal together, that's when you're worried about charges. But when you have two nonmetals, you're just going to use this system. Here we got tri-nitrogen, because there's 3 of them, dioxide. Silicon dioxide, there's only one silicon. If there's only one of the second one, remember you have to use mono. Here's tri-bismuth octachloride. Okay, the numbers are there. And here's some more. Again, when you're doing the formulas, write the charges. Barium's +2, chlorine's -1. They don't equal each other, so you crisscross them. Don't put them down here, put them over here. They put opposite. Iron 3, so iron's 3. Phosphide, phosphorus is +3. So if they're 3 and 3, you don't have to do anything, just write the symbols. Okay, aluminum carbonate. Aluminum's 3, and carbonate is one of those polyatomic ions. Those are the ones in the middle. Okay, you write their formula as is, and then their charge is the number up here. This is not their charge. Okay, their charge, they'll have a little number up here, and on carbonate, it's -2. So these two, this is 3 and this is 2, so I have to crisscross them. Now, anytime you have a polyatomic ion and you need more than one of them, you need to put it in parentheses and put the number on the outside, because if I don't, it looks like CO33. I do not need 33 oxygen. I need 3 of this whole group. So polyatomic ions, you write them as their name is, and their charge is up here. And again, if their charges don't equal each other, if you need more than one, put them in parentheses. And here's nickel 2 bromide. Nickel 2 is up here, bromine 1, so I've got to crisscross them. Okay, here's some more. Silver fluoride, they're both 1s. AgF. Cobalt 2 is up here. Permanganate is MnO4. It's one of those polyatomic ions. I need more than one, so I'm going to put in parentheses with a 2. Lithium is 1. Cyanide is a polyatomic ion, Cn. It's -1, so it's just LiCn. And again, make sure you put your capital letters right. Okay. Copper 2 acetate. Okay, copper is 2. Acetate is CH3COO. You'll also see it written, you guys, as C2H3O2. You see it both ways. On the chart I gave you, it's written this way. It means the same thing, they just organize it a little bit. But acetate is +1. So again, I need 2 acetates for every 1 copper, so that's why I put in parentheses and put a 2 by it. Okay, this is all writing formulas. Okay, if you're doing molecular again, and I know it's molecular because there's 2 nonmetals. Okay, so nitrogen, oh, you guys, this is an N, not an Ni. I got to fix that, sorry. Just ignore that. That's N. And then trichloride is Cl3. Okay, sorry about that. I'll fix that. Dibromine, Br2, hepta-7O7 oxide. Okay, phosphorus pentasulfide, PS5. All right, so again, if there's only one of them, don't worry about it. If the second one is only one, you got to put mono. Okay, and that's chapter 2. We're just about out of time, so that worked out well. So now you have review problems from chapter 1 and chapter 2. There's one more where I put the 2 different kinds of problems together. I'm not going to go through that. You can do that on your own. And again, if you have any questions, just let me know.